We're looking at graphing quadratic equations a little earlier than week 13 because I wanted you to have some time for more practice before the final exam. So the first thing we want to talk about again is how to recognize a quadratic equation. Remember that a quadratic equation is one where you have x to the power of 2. Whenever you see x squared, we're going to know that we have a quadratic equation. Also, we should note that a cannot equal 0. If a equals 0, then this term would be 0, and we would have a linear equation. So we're specifically needing to have x squared in order to have a quadratic equation. So let's start, though, by letting b equal 0. That means that this term is 0, and c equals 0. This term is 0. So we're going to look at graphing y equals 1. We're letting a equal 1, x squared. Remember that the first method we used for graphing lines was to create a table of values. So I've got a table here with some values of x. We can substitute in x equals -2, all squared. Y is equal to 4. So we have an ordered pair at -2, 4. Let's label our y-axis and our x-axis. When x is -1, we see that y equals 1. When x equals -1/2, y equals +1/4. When x equals 0, y equals 0. 1/2 squared, again +1/4. 1 squared is 1, and 2 squared is 4. These are not straight lines that we've got here. Instead, we have a shape that's known as a parabola. Every time you graph a quadratic equation, the shape is going to be a parabola. Now, remember that for this equation, we let a equal 1. That's a greater than 0. Whenever a is greater than 0, the parabola is going to open up. So we say a parabola opens up if the closed part is at the bottom. Let's look at the domain. Remember that the domain is looking at the x values. What's the graph doing as we look left and right? Well, we can see that this graph is moving towards the left. It's going to continue towards the left all the way to -infinity. It's also continuing to the right to +infinity. The graph of all quadratic equations is the set of all real numbers from -infinity to +infinity. Let's write that down so we remember what that means. When we're looking at the range, we're looking at the y values. What's the graph doing up and down? Well, we see that 0, 0 is our lowest point. So the lowest y value is 0. It is included on the graph, so we're using a closed or square bracket. As we go up from there, we see that the graph continues to +infinity. So y is greater than or equal to 0 for the range of this quadratic equation. The vertex is the point where the graph changes direction. You can see that initially the graph, if we're reading it from left to right, the graph is going down to the right, and then it starts going up to the right. This point right here where the graph changes direction is the vertex. The vertex for this parabola is at the origin, or 0, 0. Now, we also say that these parabolas are symmetrical. That means you can fold them in half and it will be exactly the same. We would fold them in half right through the vertex. The axis of symmetry is that line, x equals 0. Notice that that x equals 0 comes from the vertex, 0, 0. So when a parabola opens up, like this one does, we say that the vertex is the lowest point. That's important to know. When a parabola opens up, the vertex is the lowest point. And you can see that here. That's why our range started at the lowest point at the vertex and went up to positive infinity. Now, again, let's think about that graph, or sorry, that equation in standard form. Remember that a cannot equal 0. We have to have our x squared. Again, we're going to let b equal 0. So this term is 0. We're going to let c equal 0. This term is 0. But this time we're going to let a equal -1. So we're going to graph the equation y equals -1 x squared. Pause your video and fill in the ordered pairs from this table of values. Are these the values you got? Remember, you had to be careful about that because this negative sign is outside of the x. So we had to say the negative of -2 squared, the negative of -1 squared. Let's plot those points. We'll label our x-axis and our y-axis. We have a point at the vertex, -1, -1, -2, -4, and at -0.5, -1/4, +0.5, +1/4. We again have that shape. We again have a parabola. But this time, because a equals -1, which is a less than 0, we see that the parabola opens down. When we look at the domain left to right, we see it continues infinitely to the left and infinitely to the right. So the set of all real numbers. Remember, I said that that is the domain for all quadratic equations. What about the range? What's the lowest point? Well, we can see that this graph is continuing down to -infinity. The highest point on the graph is here at the origin, where y equals 0. A closed bracket here because that point is included on the graph. This is y less than or equal to 0. The vertex. Remember, we said the vertex is the point where the graph changes direction. Here we see our graph going up to the right and then changing direction, going down to the right. The vertex at 0, 0 is the point where the graph changes direction. The axis of symmetry is that line where we can fold the parabola and it's exactly the same on both sides. Again, it's that line straight through the vertex. Again, where x is equal to 0. When a parabola opens down, we see that the vertex is the highest point. Take some time now and practice graphing these two equations, y equals x squared and y equals negative x squared, and make sure you understand the domain and range for each of them, the vertex and the axis of symmetry.